right, welcome. Um, so we have a total of 5 geometry worksheets, starting with 205 angles. You have 205 angles, 206 triangles, 207 circles and conics. This is 208 quadrilaterals and polygons. And then the last one, and the one that we'll probably spend the most time on, is the trigonometry one, which is 209. But let's talk about 208 because that's why we're here and that's what we're looking at right now. So as far as quadrilaterals and polygons go, for the most part, you're employing a lot of the knowledge you already have about understanding angles, about creating triangles. That said, we will talk about how to get the area of a trapezoid because I've found that that tends to come up maybe once every 4 or 5 tests, but it's just very useful to kind of know. And we'll take a look at some of the harder quadrilateral and polygon problems from previous tests. So you can kind of look at the notes. This just explains that 4-side figures add up to 360 degrees. If it's a 5-sided figure, you just add another 180 degrees. So a pentagon is 540 degrees for all 5 interior angles. A 6-sided figure, you just add another 180 degrees. So it would be 720 degrees for all interior angles. And we'll talk about that. But anyway, first off, a parallelogram. So cool thing about a parallelogram is you can apply a lot of what you've known about kind of a transversal with 2 parallel lines. So the first thing you would note is that if this were 60 degrees, let's say, this one would be 120, right? So we know that about when you do a transversal with parallel lines, that the 2 interior angles will add up to 180 degrees. Well, if we wanted to turn this into a parallelogram and just draw another line that's parallel with this line, well, then we would know that this would have to be 60 degrees, and this would have to be 120 degrees. And then we could figure out all these other angles just based off of what we know with a transversal that cuts through parallel lines. So that's just something that's very handy to know. So like this angle, if this were, let's say, 30 degrees, this guy would have to be 150 degrees. And how do you get the area of a parallelogram? Well, real quickly, if this were, let's say, 13, and this were 12, and this were 20, you would do base times height. So what you would not do is you would not take the slant height. You would not use the 13. That's a prop. It's there to try to get you. Really, it would just be 20 times 12. Right. And in this case, we'd be looking at 240. Okay. Anyway, let's kind of look at some of this other stuff. Okay, so I hinted at it. Now let me actually kind of show this. And we'll also see a problem from a test where you'll see why this is important. But let me just draw an isosceles trapezoid. Try to make it look isosceles. I'll do my best. Drawing is not my strength, as you can see. All right, let's pretend this is 8. Let's pretend this is 12. And let's pretend the height is 4. So the way you'd get the area of this is you would actually average out the 2 bases. So it would be 8 plus 12 divided by 2. So in this case, 10. And you'd multiply it by the height, which is 4. Not the slant height. So not like if this were, let's say, 5, and this were 3, 3, 4, 5 triangle. You would not multiply it by the slant height. It's just the average of the 2 bases times the height. So this one would end up being 40. So the question is, why is that? And conceptually, it makes tons of sense. Watch this. If I were to just go out halfway, so I were just to kind of go out to this point. So I'm going out 1, I'm coming in 1, and I'm turning that into a rectangle. I'm going out 1, I'm coming in 1, right, from here, and I'm turning this into a rectangle. What you'll notice is this triangle fits into there. This triangle fits into there, or it would if I drew that better. But anyway, if you think about it, a trapezoid can be, if you just average out the 2 bases, if you just take the base in halfway and take this base out halfway, and same on the other side, if you average out the 2 bases to 10, you've created a rectangle. And the area of a rectangle is base times height. So the area of a trapezoid is the average of your two bases times your height. Okay. Hopefully you're already familiar with this. I kind of talked about it a moment ago, but the formula for the sum of the interior angles of any polygon is 180 times the number of sides, so n is sides minus 2. So if you put in a 3 here, let's pretend this is a triangle. If you put in a 3 here, you get 1 times 180. So a triangle is 180 degrees for all the interior angles. If you have a 5-sided figure, it would just be 180 times 5 minus 2. And in this case, as you can see right here, that would be 540 degrees. Every time you go up 1 in sides, you add another 180 degrees. And if it's a regular polygon, meaning that all sides and angles are congruent, meaning the same, then you just take the sum of all the angles and you just divide it by the number of angles, and you get the measurement for each angle. Okay. Anyway, that's all for the intro. Now let's just look at, I've circled 5 problems that have given students difficulty in the past. So let's look at these. As always, you can pause at any point and try the problem yourself. You do not have to ride along with me if you don't want to. Okay. 24. So let's take a moment to read it. This is, by the way, this is a good trapezoid problem. So we're starting off immediately with a nice trapezoid problem. So it says the side lengths of the flat trapezoidal ceiling of a bedroom are given in the figure below. Marie will paint the entire ceiling with 1 coat of paint using paint that is priced at $8 per quart and is sold only by the full quart. Okay, so Marie, no like buying parts of quarts here. You got to buy the full thing. Each quart of paint covers an area of 90 square feet with 1 coat of paint. What is the total price of the paint that Marie needs to buy? So we're only doing 1 coat of paint. Marie's kind of lazy. You're really supposed to do more than 1 coat, but I guess Marie's taking a shortcut. Anyway, let me stop cracking at Marie and let's talk about this problem. So it's a trapezoid. It's not the isosceles trapezoid that we had earlier, but if you think about it, if I go out halfway and I come in halfway, then we've just created a rectangle again. So if you think about it, the average of our two bases is going to be 12 plus 24 divided by 2, so 36 divided by 2, which is going to get us did I do that wrong? 24, 12, 36, no, so that's going to get us 18, okay? And once we have, so if you think about it, like from here to here is 18, so this new rectangle is just going to be 18 times 16, right? And that's going to get the area of the entire thing. So if we think about this, 18 times 10 is 180. 6 times 18 is, actually, let me not do it that way. I'm going to just go for the tried and true old-fashioned way. Okay, so 48, 4, 6, 10, 0, get rid of that, 8, 1. So we're looking at 288 feet. So we need to paint 288 feet, and if we need to paint 288 feet, we're dividing that by 90 to figure out how many quarts of paint we need. Well, 90 is going to go into this 3 times and change, right? 90 times 3 would give us 270. So 3 quarts of paint isn't going to be enough. We need 4 quarts of paint to really have enough paint. So $8 per quart, 4 times 8, 32. So we're going to need $32 for this job. Awesome. So I know what some of you guys are thinking. Some of you guys are thinking, I didn't need to know the area of a trapezoid to get this one. Why are you forcing that down my throat? Well, you're right. For this one, you could have dropped an altitude here. Because from here to here is 12, you would have known that from here to here is 12. So you could have done 12 times 16 plus 12 times 16 divided by 2, right, to get the area of the entire thing. So if we're looking at 12 times 16, we're looking at 192, 192 divided by 2, give us 96. Add those together. We're looking at 288. So you would get exactly the same area you got before using the method for a trapezoid. But I'm going to show you the last problem we do on this video. You're going to see why you want to memorize the formula for a trapezoid. You'll see why it may be necessary. So it's just the average of your two bases times your height. Easy enough to remember. Anyway, let's move on to the next problem. Okay, so in a certain rectangle, and again, feel free to pause and try this on your own if you'd prefer. But in a certain rectangle, the ratio of the lengths of two adjacent sides is 5:2. If they give you a geometric figure and it's not drawn out for you, you want to make it. So we know that if this is 2x, this is 5x. I'm not calling it 2 and 5 because this could be 20 and this could be 50, or this could be, I don't know, 4, and this could be 10. We just don't know. So I'm just putting x next to it. So if the area of the rectangle is 90 square inches, what is the length in inches of the longer side? So it really wants to know what's 5x. So now that we've drawn this out, this is actually quite easy. It's base times height, so that's 2x times 5x, so 10x squared equals 90. Divide by 10, x squared equals 9. X is going to equal 3, and if we plug in the 3 for the x, we get that the long side is going to be 15. Awesome. 27 is a favorite problem of mine for several reasons, and feel free to pause it and try it out. My tip for you would be just do it with your eye. Be logical. There's really no math that you have to do here. All right, but it's a last chance to pause it. I'm going to keep on going. All right, so in the figure below, E lies 3/5 of the way from B to C. Okay, so like if this were 3x, this would be 2x, right? And then the area of AED is what fraction of the area of the entire rectangle. So the area of this triangle is what fraction of the entire rectangle. Okay, real easy way to do this. If you're just using your eyes, you can kind of just estimate what you think it is. So does it look like a half? I don't know. It definitely doesn't look like 2/3. That looks too high. Does it look like 2/5? Does it look? It's definitely not 3/10. So you could try to estimate it. Here's what's really cool though. If we just move this E along all the way to the edge here, so pretend the E is where the C is, you'd go, oh, and let me redraw this. This will be easier to see if I redraw it. So if I just move the E where it wasn't 3/5 of the way through, but it was all the way at the end, you'd go, oh, it's half. Well, guess what? It actually doesn't matter where E is. The area of this triangle is always going to be half of the area of the entire rectangle. How do we know that? Well, I'll tell you how we know that. The area of this rectangle is the height times the base, right? Well, if you look at so the area of the rectangle is base times height. Right. Well, the area of this triangle is going to be base times height times 1/2. And look, the height is the same height as the rectangle. The base is the same base as the rectangle. So you literally know that the area of the triangle is going to be half of the rectangle. You may not see that though. So you can always kind of use your eyes and take a guess. Also, it doesn't hurt going back to the original one. So I know we know the answer is going to be 1/2 now. Going back to the original, it doesn't hurt to just throw in values. So call this 3, call this 2. So this whole thing is 5. I don't know. Call this maybe, I'll call it 1. I know that's not drawn to scale. So the area of the rectangle would be 5. The triangle would be 5, right, for the entire base. 5 times 1 divided by 2. So 5 times 1 divided by 2 would be 2.5. So sometimes when you're dealing with proportions and you're not sure what you're looking at, just helps to throw in numbers just to get a sense of what's going on. It will, at the very least, it will help you better understand the problem. So don't be afraid to try that. Okay. So two more problems. This problem's really cool. So we have rhombus RHOM. It's shown in the figure below. If HR is 5 and HM is 6, then what is the length of OR? I'll do OR in red. So I think the coolest way to get this one is to realize that you have a right triangle. And if H to M is 6, then this is going to be 3. So immediately you go, it's a 3 blank 5 triangle. So hopefully you remember your Pythagorean triplets. 3 squared plus 4 squared equals 5 squared, right? 9 plus 16 equals 25. So this is a 3, 4, 5 triangle. So 4 plus 4 is 8. So R to O is 8. If you weren't sure how to go about it, you could always, so say you didn't notice that you could create a triangle there, you probably would, but say you didn't. Well, if this is what 6 looks like, you know from here to here has to be more than 6, right? Just logically. So bang. Anyway, one more problem. So I told you I was going to show you a trapezoid again. Here it is. So and this is one where you're not going to be able to solve it by making triangles, unless you're kind of estimating numbers. It really just helps to know the area of a trapezoid is the average of the two bases times the height. So if we look at this one, it says in trapezoid ABCD illustrated below, AB is 8. So they give us one of the bases. CD is 12, so they've given us both bases. So the average of these two bases is going to be 10. And EF, oh, they give us the height is 6. They give us that these are right angles, and it wants to know, that's kind of, I don't think that really helps much. Actually, it does. It lets us know that this is a straight line. It lets us know that this is the height. So it wants to know what is the area of ABCD. So now that we know how to get the area of a trapezoid, this problem takes us less than 15 seconds. We know that it's going to be 60. If you had to break this up into triangles, it would be a little trickier. You'd have to maybe make some estimates because you don't know exactly what here to here would be. So you'd have to kind of estimate, and you'd have to make sure that your estimates were kept in line, that from here to here is 8, and this plus this would have to equal, make the whole thing, this whole line equal 12. So it'd be a little more complicated. But anyway, I hope this video is helpful. Good luck on these polygon problems. And the next video is trigonometry. That will be the next one. All right, good luck.